Given that Julia has its roots in the scientific programming, it is not a surprise that it has a large support for all sorts of mathematical operations. But let's start from the basics. All standard arithmetic operators like plus, minus, multiplication and division are supported in the obvious way. In particular, to rise to power, we use this syntax. And when the base is the Euler number, we can use either the Euler number itself that we can create with typing Euler, or we can use exp as a function. In both cases, we raise the Euler number to 2 in this case. The opposite we obtain with log, and we can even use log to a custom base 10 in this case. Then we have the integer division with this symbol here that again we can obtain by typing div, and in this case is 2, and the remainder that is called with this symbol that is called the module operator. Finally, another important aspect of Julia is that having the roots in scientific programming, really we have here even not only integers, float, but we have the exact rational, and we have even irrational constants. So with this syntax, with this 2 bar, we create an rational number, and we can add them and obtain this number here. Okay, so I can give it a name, and I can see that type of A is a rational integer. We have also some particular irrationals, like the Euler number that we already saw, and the P constant that we have even 2 different ways, P or using the symbol for Pi. And we can see here that the type of these constants is irrational. So we have integer, we have float, but we can retain the exact rational number using this syntax here. The nice things of using rational numbers is that during the computation you don't lose precisions like you would do if you use a float number. So at the end, when you obtain your rational number, you can always convert back to a float. We'll see this convert function later more in detail when we'll speak about types. One point to put particular attention in Julia is the quotation mark. While in most other programming languages single quotation marks and double quotation mark are equivalent, in Julia they behave differently. In particular, the single quotation mark is used to define individual character, a single letter, a single number, a char, as you can see here, while the double quotation mark is used to define strings. And of course, you cannot use the single quotation mark for more than one letter, and you will get an error. So this is 2 different things. Remember it. We have another similar symbol that is called the backtick, like here, this one here, and this one is used for one very specific subject, but is to define a command. So in Julia, you can define a command like this hello, that is a Unix command, using backticks, and then, and we'll see this later, you can run the command, for example, on your operating system. Finally, you have also a specific meaning for free double quotation marks, like in these examples. These are used for multi-line strings. Indeed, you can have you can see them here. They embed the line, but if you print them, this multi-line, they retain their multi-line nature. These free double quotation marks are used also for some special functionality that we will see later when we will study metaprogramming. That is it string macro. So this is just one example of a markdown string. So here, if I type F, I can see that I have retained a markdown string. However, this is not related only to markdown. This is not restricted to markdown. But in general, this syntax here is a string macro, and is very, very powerful, as it can add many functionalities depending on the implementation of the macro.